Hello, this is Kathy V. Mamangbang, and I'm going to present about the process and service management mastering Linux system administration. So in understanding processes, daemons, and systemd, at the heart of every Linux system are processes running instances of programs. Among these, daemons are special background processes that quietly serve system or user needs, like web servers or database engines. Enter systemd, the modern init system and service manager that has become the standard in most Linux distributions, replacing older systems like sysvinit and upstart. It's the central point for managing the lifecycle of services, their dependencies, and how they use system resources. How systemd works, units, and services. There are three units and services. First is the modular units. The second one is the service definitions. The third one is the dependency management. In modular units, systemd's building blocks are units, three ranging from services, or that service, into sockets, that socket, and targets, that target. Each defines a piece of system configuration. In service definitions specifically, service files contain precise instructions on how to start, stop, and restart a particular service, including its runtime environment. In dependency management, systemd intelligently uses dependency trees, ensuring services are started in the correct order during system boot or when a service is called. In controlling services with systemctl command, the primary command line utility for interacting with systemd is systemctl command. It allows administrators to manage services with simple, intuitive commands. When you start a service, use command sudo systemctl start apache2. When you stop a service, use command sudo systemctl stop mysql. When you restart a service, use command sudo systemctl restart apache2. When you enable at boot, use command sudo systemctl enable mysql. When you check the status, use command systemctl status apache2. And disable at boot, use command sudo systemctl disable httpd. In monitoring resource usage, your essential tools, first command is the psaux, provides a static snapshot of all currently running processes, detailing CPU and memory usage, process ID, and command. Great for quick checks. In top, your top command, it offers a real-time dynamic view of system processes. It continuously updates, showing CPU load, memory usage, and the top consuming processes, interactive and powerful. In H2O paid command, or htop, it is an enhanced interactive version of top. It provides a more user-friendly interface with color coding, easy filtering, and a clear tree view of processes, a must-have for active monitoring. And systemd9's role in resource management, systemd doesn't just manage services. It's a powerful tool for controlling how those services consume system resources. In cgroups integration, it leverages Linux control groups or cgroups to finally allocate and isolate CPU, memory, and I/O resources for each service or process. In unit file configuration, resource limits are example in CPU quota equals and memory max equals as the command used. It can be configured directly within service unit files, providing granular control. In system stability, by setting these limits, systemd prevents individual services from monopolizing resources, significantly improving overall system stability and performance. In monitoring systemd services, the status and logs, beyond simple start or stop commands, systemd provides robust tools for deeper inspection and troubleshooting of services. In real-time status, use command systemctl status service. This command is your first line of defense, offering a quick overview of a service's current state, recent lag entries, and active processes. In detailed lags, use command journalctl-u service. For in-depth troubleshooting, journalctl allows you to view all historical lags specifically for a given systemd unit, filtering out system noise. Next is the real-world scenario with its crashed Apache service. It is a common challenge for administrators. your web server goes down. So here are 3/4 how systemd helps you fix it. First step is to detect the crash. Run the command systemctl status Apache 2. If it shows failed or inactive or dead, Apache has crashed. Second step is restart the service. Execute the command using the command sudo systemctl restart Apache 2. This attempts to bring the web server back online. The third step is investigate root cause. It used the command journal-ctl-xeu Apache 2 to review recent logs for errors that explain why Apache crashed initially. The fourth one is configure auto restart. Edit the Apache service file like etc/system/multi-user.target-once/apache2.service and add restart equals on-failure under the service section to ensure it automatically recovers. And real-world section, in real-world scenario, handling MySQL crash, database service failures can halt applications. Quickly diagnose and restore your MySQL service. Initial check and restart. Verify status. Use the command systemctl status mysqld. When you attempt to restart, use command sudo systemctl restart mysqld. In review logs, use command journal-ctl-u mysqld for error messages. In deeper monitoring and prevention, resource spikes. Use stop or htop during restart to identify any excessive resource consumption. In proactive alerts, implement systemd pod units or dedicated monitoring tools to trigger alerts the moment a service fails, allowing for immediate response. In persistent configuration, ensure restart equals on-failure or restart equals always is set in the MySQL service unit for automatic recovery. So in conclusion, effective service management for reliable systems, mastering systemd and core Linux tools empowers you to build and maintain resilient, high-performing systems. These skills are fundamental to any successful IT operations. That's all.